right, so now we're going to look at domains and compositions. So let's think of our two functions. F of x equals x squared. This has a domain of all reals and a range of x greater than or equal to 0. Square root of 2x minus 1, well, I know that I can only square root numbers that are 0 and higher. So this is 0 when x is a half. And it's positive for all x values greater than a half. So my domain is x greater than or equal to a half. My range is going to be x is greater than or equal to 0. Sorry, not x, y. Or, oh goodness, I did that in both places. So my y values are greater than or equal to 0. Find f of g of x and simplify. All right, so f of square root of 2x minus 1. I'm going to take that and plug it into my f function. So square root of 2x minus 1 squared is, of course, just 2x minus 1. But now here's where it gets tricky. So while this simplifies to this single function, it originally started this way. The domain of this function was x is greater than or equal to a half. So that's going to be my domain of this function. This function is only going to be true for, so my domain here has to be x is greater than or equal to a half. Let's go ahead and test that. I'm going to open up a Desmos window here. So my f of x is x squared. And Desmos does just fine with function notations. So f of x equals x squared, g of x. I'm just going to type sqrt, and it gives me the square root symbol, 2x minus 1. So notice, here's my domain of x greater than or equal to a half. And now I'm going to say y is equal to f of g of x. Notice, it looks like that straight line, y equals 2x minus 1. I'm going to turn this into a dotted line. And let's make it a bit bigger for us. Okay. But notice that my green function only exists starting at a half and going up. Because if I try to put in any other value over here into my f of x, well, it's going to be undefined first. So my domain has to be x greater than or equal to a half. My range, it doesn't ask me for range, but I'm going to do it anyhow, is going to be greater than or equal to 0.